Hello everyone, in this video we're going to be solving an equation that's pretty interesting. Our equation will have two variables, x and y in it. So at this point you can just go ahead and pause the video and try the problem yourself first. Okay, so let's get started. We have x squared plus 1 over x squared is equal to 2 to the power 1 minus y squared. So if we only had one variable, then we could hopefully proceed like normal. But now we have two variables. And it's not a system of equations, right? We only have one equation, but two variables. So how do we go about that? Well, in these cases, most of the time we use inequalities. So that's what we're going to do today. Let's go ahead and use an inequality. We have something called arithmetic mean, geometric mean inequality. We can also call that AMGM. And this is how it works. If you have two numbers, then their arithmetic mean, which is half of their sum, is always going to be greater than or equal to their geometric mean, which is the square root of their product. Of course, A and B need to be non-negative here. So we're going to apply that to our situation. If we do, we get the following. And from here, actually, I can get a better version. Let me go ahead and multiply both sides by 2. Then I'm going to be getting this inequality here. A plus B is greater than or equal to 2AB. Now, we can easily prove that because if you go ahead and subtract 2 root AB from both sides, you're going to notice that this is actually the square root of A minus B, which is obviously always non-negative. Okay? Okay, so how do we use that in our problem? Well, we're going to take A and B as these two numbers here, x squared and 1 over x squared. So we're going to have their arithmetic mean first, which is their sum, x squared plus 1 over x squared. So I'm using this version here. That's going to be greater than or equal to 2 times the square root of x squared times 1 over x squared. And obviously, they're going to cancel out, and we're going to get x squared plus 1 over x squared being greater than or equal to 2. Okay, now what is the good thing about this, like using an inequality? Well, this is going to give us a lower bound or an upper bound. If we know that, we're going to be solving this kind of like a Diophantine equation, but in the real sense, because this should give us some good information. So we know that the left-hand side needs to be greater than or equal to 2, right? Now, what about the right-hand side? Well, if the left-hand side is greater than or equal to 2, that means the right-hand side also needs to be greater than or equal to 2 because they're equal, right? But do we have more information on the right-hand side? Yes, we do, because now this is a different scenario. We have 2 to the power 1 minus y squared. Now, what do we know about this? Well, y squared cannot be negative, right? So y squared is always positive or 0, which means that if you subtract it from 1, the answer can be 1 or less than 1, right? So basically, we can safely say that 1 minus y squared is always going to be less than or equal to 1, right? Okay, because you're subtracting a positive quantity, and the highest it can be is 1. Okay, so what does that have to do with our example? Well, it's 2 to the power this, so if you raise both sides to the power 2, then you're going to be getting 2 to the power 1 minus y squared is less than or equal to 2 to the power 1, right? And this means that 2 to the power 1 minus y squared is less than or equal to 2. And this makes sense because you're raising 2 to the power something, and that power is actually less than 1. So think about it. Let's say it's like 0.5, okay? 2 to the power 0.5 is the square root of 2, which is about 1.4. So that's definitely going to be 2, less than 2. If you think about the extreme case where y is 0 or y squared is 0, then the left-hand side is going to be 2, which is less than or equal to 2 again. So the maximum this can be is 2. Okay, this expression can be 2 at a maximum. Well, what does this mean? Now, we have the two different sides of the same equation having different types of inequalities. The left-hand side of our equation needs to be greater than or equal to 2. The right-hand side of our equation needs to be less than or equal to 2. But it's impossible for them one to be greater than 2, the other to be less than 2. Which means that they both have to be less than or equal to 2 and greater than or equal to 2, meaning that they have to equal 2. The only way this is going to work is if both sides are equal to 2, meaning that this needs to equal 2 and this needs to equal 2. Okay? See, this is the beauty of using an inequality solvent to solve an equation, because we get two equations from one. All right? Now, this should be fairly easy to solve, right? You can get x equals plus minus 1 from here, because this one, well, the sum of which number and its reciprocal is equal to 2, the only number that satisfies is 1. But since x squared can be 1, then x can be plus minus 1. And from the second equation, we get that 1 minus y squared is equal to 1, meaning that y squared is equal to 0. Okay? And so what is that going to give us? This is basically going to give us the following solutions. We're going to be getting 1, 0, or negative 1, 0 in this case. Okay? Thank you for watching. Please comment, subscribe, and like the video. See you in the next one. Bye-bye.